We are about halfway through 4th grade, and that brings me to today's topic, which is a little bit divisive. Today we're talking about fractions, and fractions are, for a lot of people, the first really big stumbling block that they hit when they're learning math. Up until fractions, everything is sort of couched in whole numbers that you can visualize, right? Even if some of the numbers are unrealistic, like 50 melons and 30 melons or whatever, at least you can visualize that. You can visualize 5 rows of 10 melons and see that that's 50. Fractions get a little bit tougher to intuit. And also, fractions tends to come with a lot of rules that teachers teach as rules rather than telling you why they work. And it's your first time where you really have to sit down and memorize a bunch of rules without necessarily knowing what they mean. So I'm hoping today I will remove that part of learning fractions, tell you why the numerator is called the numerator, why the denominator is called the denominator, and why having a common denominator between 2 or more fractions is so important if you're going to try to count or add or subtract them. So, without further ado, let's go ahead and talk a little bit about fractions. Excellent. Okay, so usually with fractions, the most common thing that I see is either cakes or pizza. And in fact, if you check in the information and on this YouTube video, I will have linked an earlier video I did with a fantastic cartoon called The Weird Number, which really does a great job of demonstrating how one fraction can be written in a bunch of different ways, and we're going to get to that in a little bit. But for now, let's say we've got 2 pizzas, and I'm just going to go ahead and copy and paste. So we've got 2 pizzas that are the same size right there, okay? And let's say that one of them is cut into 3 more or less equal pieces, okay? I'm not a perfect artist. Those are definitely not 100% equal, but we'll figure it out. The second one is cut into 4 equal pieces. Okay? So imagine you want a piece of pizza, or you want a couple of pieces of pizza, and you send someone inside, hey, can you get me a couple of pieces of pizza? The problem here is that these pieces are not created equal, right? The pizzas are the same size, but these are not the same kinds of pieces. The one that's cut red has only 3 pieces for a whole pizza, whereas the one cut blue has 4 pieces for a pizza. That means that these pieces up here are bigger, right? If you want to get as much pizza as possible, you want this piece, not that one over there. And that's a problem. It makes it very difficult to kind of try to make things fair. This one's got 3 pieces. This one's got 4 pieces. So the trick here, and the reason why common denominators are so important, is that it gives us a chance to actually compare pieces that are the same size. And once we have pieces that are the same size, we no longer have to worry about how big each piece is. I don't have to send the person outside saying, do you want a big piece? Do you want a little piece? Which one do you want? Instead, if we could divide these pizzas up into a more even number of slices each, then each slice will be the same, and all we have to worry about is how many of them there are. Now, I want you to think of the denominator, the number of pieces each pizza is cut into. So it determines effectively the size of the slice, right? The more pieces each pizza is cut into, the smaller each slice is going to be. That's the denominator. It's the bottom of the fraction. The numerator is just how many pieces you have total. If someone came inside and said, hey, how many pieces of pizza do we have right now? Assuming both of these pizzas are full right now and nobody's eaten anything, we could say, yeah, there are 7 pieces there, right? 1, 2, 3, 4, 5, 6, 7. There are 7 pieces, but we would have to then specify that some of them are bigger and some of them are smaller. I want to make each piece the same size. Now, we're going to talk a little bit later on how exactly I decided to do this, but because this right pizza is cut into 4, I'm going to take each of the 3 pieces of this 3-piece pizza, and I'm going to cut it into 4. So I'm going to go cut it in half, cut each half in half. Again, those are supposed to be equal sizes. Bear with me. Cut it in half. Cut each half in half. Boom, boom, boom. I have now cut every one of these pieces into four equal-ish pieces, okay? Which means there are now how many pieces? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are now 12 equal pieces of pizza on this pizza. So now we're going to do the same thing with the other one, except we're going to take each fourth and we're going to cut it into 3, okay? Cut it into 3, kind of like that, kind of like that. Okay? If you look close, you'll see that each of the pieces we used to have has now been cut into 1, 2, 3 pieces for a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 pieces. So now, despite my bad artwork, assuming that all the cuts were made straight and everything was cut perfectly, we now have 2 pizzas, both of which are the same size, and both of which have been cut into 12 equal pieces. Now every single piece is the same size, and you don't have to worry about what size piece you're going to get. You're going to have to get more pieces overall, but it means that each piece is the same size. And that's what you're doing when you take a fraction and put it into a common denominator. When you go to get a common denominator, this is what you're doing. You're trying to make the 2 or more pizzas all have the same size slices so that you can count them up without having to worry about different denominations, different denominators. That's the idea. So let's do another example with circles. Then we're going to move on to a different technique that I like using a little bit better. Okay. Let's say I've got one circle that is cut in half, and I only have 1/2 of it, okay? Here's the one piece that I've got of this pizza that's been cut in half. The other half's already been eaten, okay? And then this pizza over here is again cut into 4 pieces. And we'll say that, again, one of them has been eaten, so we have 3 right now. And I want to know how many pieces of pizza do I have together total. Welcome, Jamay. Glad that you're here. I'm going to get through this really quick, and then I'm going to ask for questions if you have any. So we want to know how much pizza do we have total. Well, I've got over on the left here a half a pizza. Yeah, there's 1 piece out of 2 pieces. So the top is how many pieces we have. Oop, that's behind me. And again, the denominator, the bottom, is how big is each piece. How big is each piece? So there are 2 pieces, or the pizza's been cut into 2. We have one of them. We have 1/2 of the pizza. That's the general idea of what numerators and denominators are. I will leave a link to a video in the information to give a little bit more detail on why they are called numerator and denominator, what those words actually mean. And then over here, in fact, let's go ahead and make that one red. Over here, we have 3 out of 4 pieces. Yeah? Pizza's cut into 4. We've got 3 of them. These are not equal, right? I would much rather eat that red half a pizza, assuming I'm hungry, than one of the smaller pieces over in there. And yes, you are indeed correct, Jamay. Well done. So the solution here is to take this piece, or this pizza that's cut into 1/2, and just cut it again. If I cut it horizontally, now you can see that the 2 pizzas now each have 4 equal pieces. What did I actually do there? Well, I took each of the potential slices, right? Each of the slices that there were, I cut them in half, which means there are 2 of them now, right? I doubled the number of pieces. I also, by cutting the piece that we've got in half, doubled that as well. Yeah, I doubled the number of pieces I've got. I doubled the number of pieces that the pizza is actually cut into. So in effect, I am multiplying this 1/2 by 2 on the top, because again, I'm cutting the actual piece I've got into 2, divided by 2 on the bottom, because again, I'm taking the whole pizza and cutting it one more time in half. Now, mathematically, what are we really multiplying by? Well, 2 over 2 is just 1, right? 2 divided by 2 is 1. We are 100% allowed to divide or to multiply by 1. One of the first things you learn when you learn to multiply is that when you multiply by 1, it doesn't change the number. It does change a little bit how it looks. We multiply by 2 on top. We multiply by 2 on the bottom. We get 2 over 4. Plus 3 over 4. Now each pizza is in the same denomination and we can add them up directly instead of having to have them be different. And I really want to focus in on the idea that when you are adding fractions with the same denominator, you are really just counting blocks. If I have 2 blocks here and 3 blocks over there, I've got a total of 5 blocks. If I've got 2/4 here and 3/4 over there, I've got a total of 5/4. Okay? Again, this stuff really is difficult for a lot of folks, and it's hard to visualize, so I'm trying to make it as visual as I can. Let's do 1 or 2 more examples, then we're going to jump into Khan Academy. Now, in a lot of these instances, we use circles, but as you saw earlier in my previous attempt, circles are not always easy to cut evenly. So I actually use a slightly different visual method, and you tell me whether this works or not. So I'm going to actually make a square. And again, I'm going to copy it, and again, I'm going to paste it. Now, this visualization technique really only works with 2 fractions, maybe 3 if you're very imaginative. So this doesn't really generalize to 3 or 4 or 5 fractions, but we're going to start simple, okay? Let's say we've got a number like, I don't know, 3/4, and we want to take away, let's say 2/5, okay? 3/4 minus 2/5. So in order to do this, we're going to start by finding out how much we've actually got. So I'm going to take this left square and I'm going to divide it into 4 pieces, right? 3/4, and I'm going to color in 3 of them. So the way I cut something into fourths is I'll go in half, and then I'll take each half and cut it in half. And we've got ourselves 1/4, 1/4, 1/4, and 1/4. Yeah? And I am filling in 1, 2, 3 of them to show that we have 3/4. Okay? Fair enough so far. On this other one, we have 2/5. Now again, not the same denomination, and I'm hoping this will make sense. I'm going to go ahead and cut this side to side, horizontally instead of vertically, and you'll see why in a minute. Now, cutting into fifths is a little bit tough. I'm just going to kind of eyeball it. 1, 2, 3, 4, 5. Those are clearly not exactly equal, but use your imagination. They don't have to be. This is just a visual metaphor for a mathematical process. It doesn't have to be perfect. Okay? Okay. So, 3/4 minus 2/5. Now, the way I kind of show this on how to get a common denominator, again, imagine these are cakes or imagine these are pizzas. I used to have rectangular pizzas when I was in elementary school. Imagine that they are rectangular pizzas that are being cut into rectangular pieces. Yeah? If I want both pizzas to have the same number of pieces, I can just make the same cuts again, except swapping them. So I'm going to cut this into, again, the same 1, 2, 3, 4, 5 horizontal cuts that I did before. And then over here on this, this rightmost one, I'm going to cut it into fourths just like the first one. Ooh, and I didn't actually, my bad. I didn't actually shade one of these, so I'm going to do that now. I'm actually supposed to shade 2 of them because it's 2/5. Now, if you count, and we've done this kind of counting before, you don't have to count individually. You can count by row and then multiply by the number of rows. We did that back in 2nd and 3rd grade. What I see here is that we have, let's see, 4 and 5. That's going to be a total of 20 pieces. So something is going to be over 20. And then how many of those pieces do we still have? We had 3 long rectangular pieces. We cut each one into 4 smaller pieces. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces out of 20. 15 20ths. And again, if you look, you can get 15 20ths, 15 divided by 20. Yes, it is multiplication. I am multiplying both the top and the bottom of the fraction times 5, symbolizing taking each of those 3 pieces and cutting it into 5 smaller pieces. Same deal with the 2/5 side. With the 2/5 side, we had 2/5, but each one of those fifths was cut into 4. So now we have, again, over 20. 1, 2, 3, 4, 5. 1, 2, 3, 4. 5 times 4 is 20. And we have 1, 2, 3, 4, 5, 6, 7, 8 20ths. I cannot overemphasize that we have not actually changed these numbers yet. We haven't actually changed the numbers. We haven't changed their value. All we did was cut them up into smaller pieces so that we can compare them directly, as opposed to some of the pieces are bigger and some of the pieces are smaller. And then once you are in this spot, once you are in a place where you have a common denominator, you are no longer in fraction land. You are no longer working with fractions. You are now counting blocks. If I have 15 blocks and I take away 8 blocks, I do indeed get 15 minus 8, which is 7 20ths. This is how I visualize my fractions when I'm trying to figure out what the common denominator is. You can always multiply times the denominator of the other fraction. Notice that on this side, I multiply the top and the bottom by 5, which is the denominator of the other fraction. I multiply the top and the bottom by 4, which is the denominator of the other fraction. There are other ways to get different denominators. You may have heard of the lowest common denominator. I'm sure we'll cover it at some point in this class, but you can always get a common denominator. You can always get a common denominator by multiplying the two together and working with it that way. Let me think. Let's say 5 over 6 plus, let's go with 3/4. 5 over 6 plus 3 over 4. So same deal. I'm going to go 1, and then cut each one into thirds, so that'll be 6. Okay, we've got it cut into 6. I'm getting better at this. And we've got 1, 2, 3, 4, 5 of them. Yeah, I hope the pieces are easy to see when I'm coloring them in with the same color. And we are adding, again, for the purposes of this demonstration, it is a lot easier to cut vertically on one and horizontally on the other, because then you can visualize what it's actually going to look like when you kind of transpose the two squares onto each other. 1, 2, 3, 4, and we have 3 of them. 1, 2, 3. Okay. So, once again, there are a few ways we can do this that make it, and in fact, doing it my way does not get you the lowest common denominator. It doesn't. But it does get you a common denominator. Okay? So what I do is, again, imagine in your head if you were to take these two squares and kind of overlap them on top of one another, so that every one of these 1, 2, 3, 4, 5 pieces is cut into 1, 2, 3, 4 sort of sub-pieces. So we cut it in half, cut it in half again, cut it in half again. And we've got 1, 2, 3, 4, 5. That looks like 20 right there. Correct me if I'm wrong. Out of a total of 24. So I'm going to move this up a little bit more. And we have 20 out of a total of 24. Same fraction, just in a different denomination. Plus, this one I'm going to go ahead and cut into 5 pieces. 6. So there's the middle. That's 3, 4, 5, 6. Again, I've got 24 pieces total. Count it yourself if you don't believe me. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 out of 24. Again, now that we have that common denominator, we are dealing with 24ths. We no longer have to worry about the fraction. We're just counting how many 24ths do we have. If I have a pile of 20 blocks and a pile of 18 blocks, that gives me a total of 38 blocks. We just happen to know that each quote-unquote block, each piece of the pizza, is 1/24th of the whole pizza. So we have 38 24ths, which you can actually divide the top and the bottom of this by 2 to get 19 over 12. So that's how I think about these. It's not magic. It's not some arcane spell to make it so that you can add fractions together. It's just cutting the pizza into the same number of pieces so that it's fair and you can count them fairly. Yes, I multiply 4 by 3 and 6 by 2 and it's 12. Yes, and that's absolutely correct. That is another perfectly valid way of getting the same denominator. My point is that it's not necessary. There are multiple ways. And in fact, your way is better because my way required me to simplify again at the end, right? I had to actually divide the top and bottom by 2 to get the thing in lowest terms. So if you can get the lowest common denominator in the first go, it does save you work later on. I agree entirely.